Hey everybody, I apologize for yesterday's video. I'm not really sure what happened. I must just not have turned the microphone on. I can tell you, as displeased as you were trying to watch a video without the volume, I felt the same way knowing I spent all that time trying to actually make the video and then turns out it didn't have any volume. So I apologize for that. I think I've corrected the problem. And so today we're going to talk through geometric mean. So this is kind of an extension of similar triangles. Like yesterday, we set up a lot of proportions, and so that's what this review here is at the top. Remember that if you have two proportions set up and there's an equal sign between them, so you're multiplying or cross-multiplying to solve for the missing piece. So this would be, oops, sorry, I was actually playing with my daughter on this earlier, and she clearly enjoyed the bigger writing. So 10 times x is 10x, 20 times 3 is 60, okay, then divide by 10. So in this case, x would be 6, okay. Let's move on to review question number 2. We're going to do the same thing. We're going to cross multiply. When we cross multiply, 12 times 1 is 12, x times 36 is 36x. Okay, so at this point, again, we want to get x by itself, so we divide by 36. 12 goes into 36 3 times, and 12 goes into 12 1 time, so x is just 1/3 here. Okay, so the next part that we're going to talk about today is new content, and it's called the geometric mean. So this is what I kind of mentioned in class for those of you that were there yesterday. Just talking about, like, you know, it's tough to understand what does the geometric mean actually do, or why is it important. The geometric mean is frequently used to find the return on investment for compound interest. So basically what that means is, like, let's say you invest $100, okay? And over the length of that first year, 50% of it is gone, okay? But then the second year, you gain 50% back. So compound interest basically says that even though we lost half of it the first year, we're now compounding that interest on the new balance, right? So think about that. If I invested $100, okay, 50% gone, that means after the first year I only have 50. Well, if I gain 50% of this number back, well, half of 50 is only 25. So my total at the very end would be 75, right? And so that's kind of where geometric mean comes in, is they look at the extremes, like what was the starting point, what was the end point, right? And they try to figure out what's the average over that length of time. So that's geometric mean, and it includes compound interest. So that's why it's important. We're just going to talk about the very basic use of it here when talking about triangles. So the difference between arithmetic mean and geometric mean is arithmetic is the one that we're familiar with, where you just add whatever numbers you have and then divide it by the total numbers that you had. So if I have 1 and 4, I would add them together, and since those are two different numbers, I divide it by 2, right? And that gives us 2.5. Geometric mean is where you take those two numbers, so 1 times 4, and then take the square root of those numbers, right? Or the root of however many numbers you have, I should say. So since there are two numbers, I'm taking the square root. If I had 3 numbers, I'd take the third root. So 1 times 4 is 4, square root of 4 is 2. So the average for a geometric mean in this case would only be 2, whereas the average for arithmetic would be 2.5. So sometimes it's bigger, sometimes it's smaller. Okay, so definition-wise, the geometric mean of two positive numbers, a and b, so these are the extremes like I talked about, like the very, very low and the very, very high, is a number x such that x squared equals a times b, and if you were to solve it even further, you could say that x, so if I took the square root of x squared, I would also take the square root of a times b, and that would give me the answer. So the definition there kind of tells you exactly how to find it. So we're going to find the geometric mean of these following numbers. We're assuming that these are extremes. So if this is a and if this is b, okay, then x squared equals a times b, and x equals x equals the square root of those same numbers, because I would take the square root of both sides. So x is the square root, in this case, of 5 times 8. Okay, well 5 times 8 is radical 40. Okay, radical 40 breaks up into 4 and 10. I'm going to actually push that up here. So radical 4 and radical 10. Remember, radical 4 is a perfect square, so the answer here would be 2 radical 10. Okay, so that would be the answer on that one. For 7 and 11, x equals the square root of 7 times 11. So x is the square root of 77. Okay, and we could also look at these as a decimal. So you could put it into your calculator and say, okay, what is that? I have not done that yet, so I don't know what those numbers are. And honestly, for this purpose, 77 doesn't simplify, so we can just leave it as the square root of 77. Okay, 4 and 9. 4 and 9, so the geometric mean. X equals the square root of 4 times 9. Okay, so x equals, 4 is a perfect square, and so is 9. So this is x equals the square root, this is 2 times 3, so x is 6. So as you can see, the geometric mean is not necessarily directly in the middle. Like the middle of 4 and 9 is 6.5, right? If you were to take the average, 4 plus 9 divided by 2 is 13 divided by 2, which is 6.5. So geometric mean is a little bit less. Okay, so why is it important for us today? Well, today because we're going to use it to find the altitude of a triangle. Okay, so the altitude of a triangle, maybe if it'll let me write, is a line segment from a vertex and is perpendicular, that's a U, U-L-A-R, to the opposite side. So like this is the altitude, okay? It goes from the vertex, so from a peak, and it goes straight into the perpendicular side, and you know it's perpendicular because it's 90 degrees. Okay, so that would be a vertex right here, or a altitude. Okay, so there are 3 triangles in the figure to the right. Redraw the 3 triangles with the same orientation below. So basically, we want them all to look exactly the same, only they're going to be similar triangles. We're just trying to measure up like which angles go with which. Okay, so if the big triangle is B or A, B, N, okay, now where do the other ones go? Well, if this is my 90-degree angle, 90 degree, 90 degree, let's say that this is my small side. Okay, this is my medium side, and this is my hypotenuse. So then if I'm looking at the medium one, I can see the right angles right here. It points at my hypotenuse, which is AN, and this is my small side, whereas this is my medium side, right? So small side is AT, with T being my vertex. So there's the small. And that leaves N over here. Okay, so now, with this other one, T is my vertex, because it's at the right angle. All right. My small side in this case looks to be B, and then my long side is A. All right, so we're just redrawing those triangles. They are similar, and as you can see, they kind of flip around. So you're just trying to find the corresponding angles like we did yesterday. All right, so now you can see we did this, and we can use that information to set up proportions, right? Like if we want to be able to find the side length, we can say the large and medium and say big over small, like we did yesterday. But what's nice about the geometric mean is, as we look at this demographic here, is if we're trying to find the altitude of a triangle, okay, all we need to know is what's the short side of the small triangle that's connected, what's the medium side of the medium triangle, right? So what's A, what's B? Okay, if we know this total distance, and we know one of these, at least, then we can use the geometric mean formula just to figure out x, and we don't have to go through that whole setting up a bunch of proportions, crisscross, applesauce, all that stuff. So instead, we're just going to use the geometric mean formula. So in this first example, it says if Jm equals 12, Jm being this distance right here, and ML is 9, what is KM? KM being the altitude. Well, since we know the short side, okay, just like it says up here, short leg over, since this is the altitude, and then same thing on this side, only flip-flopped. Okay, now we can cross multiply, which means x squared equals 12 times 9, right? And we could have done that from the very get-go if we looked at this and it says, look, x squared equals a times b, and then they took the square root to get the geometric mean. So x equals the square root of 12 times 9. So x is, let's see, radical 9 breaks down to 3. Radical 12 is radical 4 times 3, but 4 breaks down to 2. So this is times 2 radical 3. So x is 6 radical 3. That's our altitude. Okay, and you could also get a decimal for that. All right, same thing here. What is the value of x? So x is the altitude. This is the small side. This is the medium side. So x equals the square root of 5.4 times 15. Okay, and this one, since it's got a decimal, we're going to unfortunately have to use a decimal. So let's just go ahead and open up Desmos. Okay, the square root of 5.4 times 15 is 9. Well, that's pretty cool. Comes out to be an even number. Okay. So, your homework for tonight, complete this exit ticket. First, just determine the geometric mean of these using that formula. And then for 3 and 4, find the length of x. Okay, so you can use the geometric mean formula if it's asking for the altitude, or you can work your way backwards even, or you can even draw separate triangles if you want, so that you can set up the proportions, right? And just make sure that you have at least 2 proportions set up. Okay, let me know if you have any questions, and I will see some of you in class.